Hello everyone, it's December the 2nd. Alright, so yesterday was a fail, which is okay. It's don't really care too much. That was a hard problem. I think any day it will be a hard problem. So I just was not able to solve it. What worries me more is the problem that I did not solve on the other one. This is the more worrisome because I gave it another thought and I couldn't figure it out. There seem to be, I don't know, there are so many restrictions, right? I have to go through all these restrictions and it just, it times out, right? Actually, I didn't even run it by itself. I'm pretty sure if you run this, you'll get timed out as well. And I don't know, right? I don't know. It feels alright, but and I have all these break cases that like you will run this at the beginning and then yeah, I don't know. I don't know. I feel like it's right. Right? I feel like it's right, but it is not. And an account has to, I have all these continue, right? All these continue. And if I don't go through this, and I'll break. Right? I don't go to follow all the time, and update the rest, right? And then I keep going to the next one. If it's larger than I already break, so I don't even go through the whole thing. But this does look like all the same kind of numbers. I can understand why this is will be slow. Because the result is small, right? And every time you go through, then that's the thing. Result is small. Every time you get a new one, you get. I don't know. Maybe there's some binary search that I can put in here somewhere, but. I need even count. Right? I need even count. And technically I also need the prefix num events. So I do have a prefix sum, right? I have a prefix sum. So up into the current position, I have the prefix sum on the evens, right? How many evens there are. And I can look back because I need to know. But yeah, you see, I have this J thing, right? I have this J thing. I can say what is the largest I can get. See, that's the problem, right? That's the problem. I have to go through them all the time. Maybe you should go from right to left. Have you thought about that? Go from right to left. Seriously, go from right to left. Because if you go from right to left, you will always capture the biggest first. That actually might not be a bad idea. Okay, now we have some idea. We have some idea to improve this. I'll go from right to left. So I do one pass, left to right. I have to preview all of this, preview all of this, and then I go right to left, and I run exactly the same algorithm. Now the benefit of going right to left is you have a gigantic I, right? And then you look for the smallest exclusive OR that happened before. And if that works, then we get a big res, right? We get a big res. So any further, if you just keep working, right, then the chance of this one hitting is much higher. Much higher. I think this is very promising. Okay, so if we can solve this fast, we'll go do that one. Count number of trapezoids. So I have a 2D integer array. So it's a 1, so tomorrow might be 2. That's my guess. Points represent the coordinates. Okay. Horizontal trapezoid is a convex quadrilateral with at least one pair of horizontal sides. Two lines are parallel if only if they have the same slope. Okay. Return the number of unique horizontal trapezoids. So horizontal trapezoid. Oh, trapezoids. Okay, I see. Yeah. I actually forgot what it's called. Parallel something. Whatever. I forgot what it's called. Let's see if we can search for geometric shape. I don't even know how to describe it. Shape. 4 sides, opposite side parallel. What is it called? Parallel. Parallelogram. I guess that's how you do it. Parallelogram. Oh, this is helpful. Square, rectangle, parallelogram, trapezoid, rhombus. Rhombus. It's just the sides are all equal. And a kite. Okay. But they're all quadrilateral, right? They're all quadrilateral. I think I already gave them money. Quadrilateral and they're all considered trapezoid. At least one pair are parallel. Yes. Okay. Yeah, makes sense. It all makes sense. So one pair are parallel. And horizontal, at least one pair of horizontal sides. One pair horizontal sides. So what it's trying to say is we need to have two that are horizontal. So the pair that's horizontal must be like this. So I have, these are the points, and we need to find all of them that's horizontal. I have 1, 2, and 3. Gotcha. That's only one. All points are pairwise distinct. Okay. So horizontal, right? We need to have horizontal. So I need to find. So we're gonna have. So basically, once we get this, we basically have, some like this, right? Doesn't matter. Doesn't matter where they are. So eventually, it's gonna look like something like this. So you can draw horizontal lines. Draw horizontal lines and draw horizontal lines. So basically you get all the horizontals together, right? And then you pick any two, and you pick any two they can form. So in this case, I have this and I have this. So this will be 2 choose 2. This will be 3 choose 2. This only 1. This is 3 choose 2 is, I believe, 2 times 3. 3 times 2 divided by 1 times 2, which is 3. So you multiply this, you get 3. So yeah, I think that is. And if a line, if one of them only have a single one, then that one cannot be included. It has at least 2. Okay, let's try this approach and see if it works. 3623. Get all the points on each horizontal line. If the number of points is larger than 1, we can do combination, right? Combination on it. For example, if there are n points on a horizontal line, the total number of combinations for a side is n choose 2. And then we simply multiply all of the choices. Not all of the choices. That requires, it's not all of the choices, it's all of the pairwise choices. Because if I have this, basically this multiplied by this, and this multiplied by this, and this multiplied by this, and then we do this, this, and this, this, and then we do this, this. We have 10 to the 5th. I'm actually not sure, but we'll see if it works. So I have to produce them first. I cannot just go along the way, right? I have to produce them first. So everybody, we're gonna look at your y. And then depending on how many y's you are, I don't know how many different y's you're gonna be. And there's no modulo, so it's not gonna be too big. Combination, oh my god. You have to do, shoot. I have to write our own factorial. Damn. Yep. Let's see. C++ combination. No. Ah, you gotta be kidding me. Alright, I'm just gonna copy and paste this. Shamelessly. So yeah, basically you write a factorial, which is simple enough, and you write, we don't even need this because we know it all exists. Okay, we'll do this. Okay, this is actually good. You probably should write it yourself. It's not as trivial as you thought. So it's n factorial divided by, so n choose k factorial, n minus k factorial. Okay. Yeah, I guess we do it. All right, I'll copy and paste this. I don't like it, but it's fine. I wonder if I can just go int, you know, because at the end of the day, it's a return int. Yeah, it's a return int. So I think we probably can get away with int. Alright, so the idea is we will go through and we will have a, oh dude, we need to have a map. We need to have a map. And it's gonna be a y. I just need a count, right? So num points, horizontal points. Horizontal points. Okay, horizontal points. And then we say for point is going to be just this. So for const auto p of points right? So P, so horizontal point P is PP1, right? Plus. Okay, so this will go through everybody. And then we need to go through all of them. We need to get all the keys. And I want to produce a list for all the keys because I need to revisit them. All right, so C++, turn map keys into vector. Okay. All right. That's, I mean, it works. Keys. Wise. Okay, wise. And then we say for. How'd you get a key? Oh, const auto pair of horizontal points. We say wise dot pushback p dot first. Okay. Then we say int res equal to 0 for int I equal to 0, I smaller than wise dot size. I forgot. I need to y plus plus. Okay. So this is for int j equal to 1, j smaller than I plus 1, j smaller than y dot size, j plus plus. Okay. So what we do is combination. Oh, I shall get all the combination first, dude. Okay. So I have y's. Then why do you do y's? Right? It should just be counts. Right? Counts. So what we do here is if p dot second, which is the count, is larger or equal to 2, then we say counts. Oh boy. Dot pushback combinations. Oh yeah, I don't even care about the keys, right? So just p second, we choose 2, right? And then we say else counts dot pushback, push a 0 into it, right? So we do that. We have all the counts. Then why do you even do this pushback? You don't even need it, right? You don't even need it. I do not need it. So just like that, I'm pushing. So now counts all, yeah, counts contain everything. And then you just need to do the multiplication, right? We just say counts. This is also counts. And we say here res plus equal to counts I multiplied by counts j. And voila. And then we'll return res. I think that shall do. There's definitely room for improvement. The factorial, right? If you use a map, you can probably get it better. But I am too lazy to improve the solution. I think this is good enough. Dear me. It never says we need a mod. Oh. Dude. Yeah. I don't know why, but this is just stupid. Okay? This is just stupid. I was like, yeah, it didn't really say you need to mod. You do need to mod, dude. It has to be mod. So long, this is all fine. I think this is fine. This is not fine. This has to be long. and then we need a int mod 1 2 3 4 5 6 7 8 9. So what we do here, we're gonna do combination. Ooh, yeah, let's do mod here. So we're gonna do res multiplied by I and a mod. Okay, so here's the same thing. This is divided by divided by can we even do the mod here? I don't know. I tend to think, oh, but this has to be mod. Okay, I forgot. How do we do mod on division? Mod on division. There is some way. This is not what I'm looking for. It's I think it's like like Chinese little theorem, something like that. So A it should be like A divided by B mod C versus A mod C divided by B mod C. I don't know if this LLM can understand what I'm trying to say. Nope. What's the quotient? Mod of a quotient. No, that's not what I want. Yeah, it's not trivial. I forgot how to search for this. So product of modulo arithmetic. All right, modulo arithmetic division. Modulo division. Yes, you have to do this. The modulo inverse. Oh God. Yep, that's what we need to do. That's what we need to do. I don't remember how it's done, but we'll have to figure out. Fermat's little theorem. Yeah, Fermat's little theorem. M is prime, and we need to find what. If the modulo is a prime, we can use the Fermat's little theorem to find the modulo inverse. According to the theorem, the inverse of B Modulo b is this modulo m. So we can modulo exponential. Oh, we need to do modulo exponentiation. Oh, Lord. Alright, I'm gonna shamelessly copy everything. God, Lord, I am not going to do this. I have to copy everything. So we need, oh Jesus. Here. Alright, so we have a modulo power. So base to the that. So base, exponential larger than 0 if it's equal to 1. Which is odd, so we'll multiply the base to the result and our modulo. Otherwise, we will do this. Okay. Mod inverse is going to be Fermat's theorem. Power of this is mod inverse. Mod division is going to be division not possible. No, this we don't have to because m is a prime, so we don't have to deal with this. So inverse, we get the inverse, mod inverse, and then we do this. Okay, so factorial is fine. Yeah, let's call it m. In fact, I think we can just go with int. And then we just do long here, right? We can even take this as a long, right? For mod m, and this is the same thing, because we'll do int, blah blah, factorial. So we need to do return. We say denominator denom is equal to this times this, right? This times this, but one of them has to be long, right? This times this mod m, and then we'll return a division. So we say mod divide, right? This divided by denominator. So factorial, we have to pass m in. Mod divide, I also need m. Okay, so that's that. And we'll push back mod. And it counts as int. This one needs to handle as well, so we'll go long on this, long on accounts. See, that's why I want accounts to be long, right? I want accounts to be long, and so here this is going to be long, so I can multiply mod m, right? And then we shall say res equal to res plus this, also mod m, and then mod. Wow, I feel like I spent more time to fix this. All right, Fermat's little theorem. Yeah, we'll have to go through the Fermat's little theorem in reality. Fortunately, did we submit? Yeah, we submit, right? So use test case. Yep, that's right. No way. What? I cannot even. What? What the hell, man? And I also need to understand which part spends the most time. Okay, so I need to delete all that. I need to understand. If I don't do this, what's like how long does it take? It could be just the combination take too long. 11 milliseconds to do the combination. So can we make it better? Can we make it better? So if it's n, okay, we do memo. Let's try. We'll do 2 memos. So we do. Oh, you gotta be kidding me. So factorial memo. And we call this combination memo. Yes. So power is fine. This is fine. This is factorial. We say if fact memo dot contains and I can say not contain, right? Not contain. We will do this. And then we'll say fact memo and we're equal to res. And then we'll return. Oh, I have written already. Fact memo n. Cool. This is the same thing. This is fine. This is fine. This is also fine. Then we say if combination memo dot contains n, right? Because k is deterministic, so I don't need. So I say if it doesn't exist, then we do this. And we say combination memo n equal to this, right? And then we return combination memo n. Okay, with these two optimization, let's see the performance on this one. Same thing. We're gonna comment out this and see how much it runs. So previously is 11 milliseconds. Do we get a little bit better performance? Oh, we get 11 milliseconds. We get exactly the same. So this performance improvement did not help any bit. You gotta be kidding me. Really? How? I don't believe it. Let's also comment out this. Just see we go through the whole thing. How long does it take? Take 8 milliseconds just to do this part. Just to count the points. But to me, this is absolutely necessary. We have to go through all the points, right? Of 10 to the 5th, we have to go through all the points. And it's like 10 to the 8th, so we choose to use a map for this. That also makes perfect sense to me. So the memo doesn't really help. Really, the memo doesn't help. I don't know. Combination memo. I'm just curious. Zero? What? How? Okay, this is I don't understand. I don't understand. What? Alright, that doesn't make any sense. Shit. Okay. Oh, I see. The ones. Screw me. The ones. So you have a bunch of 1. And 1 multiplied by 1 is still 1. How do you handle the ones? Yeah, that's actually you're gonna have like repeats value, right? So I say 1 we have 10, 2 we have 5, right? So in this case, let's just go like 3 and 2. So we have 1, 1, 1, and 2, 2. So it'll be 1 times 1, 1 times this, 1 times this, 1 times this. So yeah, this times this plus this times this. So basically it's this times this plus this times this plus this times this, which is equivalent to this 1, just like A0, A1, A2, A3. I think I didn't think it through, right? A0 times A1 plus A0 times A2 plus A0 times A4, which is A0, A1 plus A2 plus all the way to A4. And then you basically this plus A1 times A2 plus the A4. So a prefix sum can handle. Yep, I don't know why I didn't think about this before. I don't know. It just makes perfect sense. So we can actually do A0 times A1, A0 plus A1 times A2, A0 plus A1 plus A2 times A3. Right, it's the same thing, just like this multiplied by everything. So I see the problem. This actually makes things slower, honestly. But just keep it there. Okay. Note that multiply all of them together. So this should be ON times the combination. That is not right. Right, result is fine. So we need a prefix sum, so pre-sum. Right, pre-sum is also is this, right? And then it's going to start from 1. So rest and plus equal to rest plus p-sum. Let's call it p-sum. Okay. So p-sum multiplied by counts I mod 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 mod. And then p-sum plus equal to p-sum plus 2 counts I mod mod. Right, and then we multiply until we hit the end, and that shall be it. I cannot believe it that I missed this part. I thought we just brute force it, which you really shouldn't. Let's also do this, use test case, reset it. Let's make sure everybody works. All right, submit. See, I'm telling you that this is not right. I think this should be long, or what? You know what? That's why I say don't do it. All right, don't do it. It doesn't take that long to go through this. So all it does is to make things complicated. All right, make things complicated, and we just return res. Here is the same thing. Don't do it. Don't do it. I betcha that the difference in time is minimal, if at all. Okay, if at all. I mean, we can definitely make it work, but like, why bother going through all this difficulty? Let me also use this test case. So 15 earlier. I think it's probably 15. Wait a second. What the hell? Huh. Where is the error? It can only be here. Oh, I chose long. It's still not right. Binding to no pointer long. I don't understand. So everybody's 1. Oh, I see. Okay, I see what happens. If count.size equal to 0, right, we'll return 0. Actually, count size is smaller than 2. Right? If I only have 1, that's also going to be 0, smaller than 2. I see, it's actually faster. Oh, a lot of iterations, man. Yeah, the most difficult part is to get C++ work. That's the most difficult part. All right, let's read the tutorial. It's pretty much should be the same. Yeah. Oh, it don't need combination. It don't need combination. Oh, you don't need combination. Because you do combination of 2. You do combination of 2. Oh man. Oh man, none of this is necessary. Crap. Ah, crap. Seriously, crap. So this is just gonna be p.second, yeah, multiplied by p.second minus 1 divided by 2, and we probably need to mod here. I guess not, because counts I do yeah, I think it's fine. We'll mod here. Yeah, holy crap. Yeah, we also don't need to go through this. We can just directly go through. Oh man, this is so bad. This is so bad. This is so bad. I don't know. Like, if things happen, like the stupid things happen to me, it does. And you just edges, right? Number of edges, this is what we have. Multiply by the sum. What is sum? Sum is the sum of edges. Yes. I would definitely submit this again because it's necessary. But p dot second. Oh, that is an int. How about we get that to long? Does it work if I get it to long? Yeah, it works if I get it to long. It's faster. Since the combination is n choose 2, we don't need to use any formula. Right? The updated version runs at 54 milliseconds. I don't know, man. Things were bad.